Space watchers around the world are gripping their telescopes a little tighter these days, because the interstellar visitor that has captured global fascination has just taken an unexpected and bewildering turn. What was already one of the most intriguing cosmic arrivals in recent years has now become an even deeper mystery. The object known as 3I/Atlas, a massive, Manhattan-sized wanderer hurtling through our solar system, has begun behaving in ways that have left scientists puzzled, curious, and in some cases, genuinely astonished. This remarkable interstellar traveler, already a source of intense debate, has now shown signs of doing something few natural objects ever do. It appears to be accelerating in a way that does not neatly fit into any known natural explanation. Even more strangely, it is turning bluer as it speeds outward, a color shift that has sparked conversations far beyond the usual astronomy circles. This sudden and unexpected change has revived whispers that 3I/Atlas might not be just another icy relic from the distant reaches of space, but something far more engineered, far more intentional, and potentially far more advanced than what humanity has ever encountered. The latest observations sent a shock wave through the scientific community when researchers noticed 3I/Atlas gaining speed as it passed perihelion, the point in its path where it comes closest to the Sun. Instead of slowing down or behaving like a typical comet under the Sun's influence, the object seemed to apply a kind of controlled acceleration, steering itself away from the Sun rather than simply being pushed by radiation or jets of evaporating material. Instruments tracking the object captured not only this unexplained acceleration, but also a surprising increase in brightness, a luminous flare that made the object appear more vivid at a moment when its brightness should have stabilized or diminished. These anomalies immediately raised a host of questions. Was this acceleration caused by outgassing, the sudden release of gas from beneath the surface, as often happens with comets? Or was it something else entirely? Something unprecedented in recorded astronomical observation? Into this debate stepped Harvard astrophysicist Avi Loeb, a figure both respected and controversial, known for his willingness to challenge traditional assumptions in astrophysics. Loeb became internationally known in 2018 after proposing that the interstellar object, Oumuamua, might have been an artificial probe or technological remnant rather than a standard comet. His hypothesis stirred global debate, inviting criticism from mainstream scientists and fascination from those open to non-traditional interpretations. Now, with 3I/Atlas displaying its own unusual behavior, Loeb has once again offered his perspective, one that takes the mystery of this object into bold and provocative territory. According to him, the new data provide the first evidence of a non-gravitational acceleration that cannot be fully explained by standard comet mechanics. In his view, this unusual behavior could be interpreted as the technological signature of an internal engine, something designed rather than formed naturally. Loeb clarified that he is not implying that extraterrestrial beings are actively piloting the object. Instead, he suggests that the acceleration pattern could be evidence of an engineered mechanism, a propulsion system built into the object to guide its movement. Traditional comets, when heated by the Sun, can release jets of gas that cause slight changes in velocity. But these changes tend to follow predictable patterns based on composition, temperature, and rotation. 3I/Atlas, however, is not following these patterns. Its trajectory, brightness, and spectral characteristics do not behave like typical natural outgassing. As Loeb explained, if observers do not detect a large cloud of gas around the object in December, it could strengthen the case that its acceleration comes not from released volatiles, but from some form of deliberate propulsion. In other words, if natural explanations fall short, artificial ones become harder to dismiss. The color shift to a bluer hue has particularly captivated researchers. In astronomy, a change toward blue light often indicates the emission of higher energy radiation or the reflection of specific materials. Comets sometimes change color as they shed dust or gases, but the degree of blue shift observed in 3I/Atlas is unusual. It suggests either a rapid alteration in the surface composition or a process occurring within the object that standard comet models do not predict. A bluer signature might indicate a fresh, reflective surface revealed by shedding layers. Or, more speculatively, it might be the emission of energy from an engineered material interacting with solar radiation in a controlled manner. While mainstream explanations remain on the table, the fact that the color shift coincides with unexpected acceleration has heightened curiosity. It is not one strange anomaly, but two happening simultaneously. And that combination has historically been the kind of trigger that prompts scientists to reconsider old assumptions. Before these new developments, astronomers had every reason to expect 3I/Atlas to behave like a typical interstellar comet. When such objects pass near the Sun, they usually brighten slightly as solar heat causes their icy surfaces to vaporize. After reaching perihelion, they tend to fade as they move away and cool. But 3I/Atlas defied these expectations in dramatic fashion. Instead of experiencing a modest increase in brightness, followed by a predictable decline, the object grew significantly brighter right as it appeared to accelerate unnaturally, almost as if reacting intentionally to its environment. Observers reported that it seemed to steer itself away from the Sun rather than simply drift along its projected path. This sort of controlled maneuvering is not something nature typically provides. If a natural process were responsible, it would need to be unlike anything previously recorded in cometary physics. The implications of an object accelerating in a directed, non-natural fashion are profound. For centuries, humanity has gazed at the stars and wondered whether intelligent civilizations exist beyond our own. While telescopes, satellites, and space probes have given us extraordinary insight into the workings of the universe, we have yet to find definitive evidence of extraterrestrial technology or engineering. Interstellar visitors like Oumuamua and 3I/Atlas offer rare opportunities to study objects not born in our solar system. They come from faraway star systems, carrying with them clues about their origins, composition, and potential creators. When an object behaves in ways that do not fit comfortably into natural models, it sparks deeper questions about whether we might be observing something intentionally sent, something built, or something operating far beyond our current understanding. Of course, many astronomers prefer caution over speculation. They point out that nature often surprises us, revealing new physical processes when we least expect them. Our understanding of interstellar comets is still young, with only a handful ever detected. There may be natural mechanisms we have not yet cataloged, complex outgassing behaviors, exotic surface compositions, or unexpected thermal reactions. But even among cautious scientists, there is growing acknowledgement that the behavior of 3I/Atlas is unusual enough to warrant serious attention. The discussion is no longer confined to fringe theories. Researchers are re-examining their models, rechecking their measurements, and publicly acknowledging that this object challenges long-held assumptions. The coming months will be crucial in determining the truth behind 3I/Atlas. Observatories around the world are preparing for continued monitoring, hoping to track its brightness, color, and trajectory with greater precision. If the object fails to produce the gas cloud expected from natural outgassing, that will embolden the hypothesis that something more structured is occurring within it. Likewise, if its acceleration continues to follow a pattern inconsistent with gravitational or thermal forces, the argument for artificial propulsion will intensify. Scientists know that extraordinary claims require extraordinary evidence, and they are gathering that evidence piece by piece. Each new observation adds another layer of complexity to the mystery. For now, 3I/Atlas remains an enigma, one that has captured the imagination of scientists, space enthusiasts, and the general public alike. Its unexpected acceleration and striking color shift have blurred the line between natural cosmic phenomena and the tantalizing possibility of engineered technology. Whether it turns out to be a completely natural but previously unknown type of interstellar object, or something far more intentional and advanced, its presence has already changed the conversation. It has reminded humanity that the universe is vast, filled with surprises, and still capable of challenging even our most confident assumptions. And as it speeds away into the darkness, glowing a little bluer and moving a little faster than it should, 3I/Atlas leaves behind not just data points for astronomers, but a sense of wonder, a reminder that we are still at the beginning of understanding what might be out there.